Redevelopment of Deepwater Old Oilfield, Liuhua Oilfield. Liuhua Oilfield is located in the sea area of the Pearl River mouth basin in the South China Sea, about 250 kilometers southeast of Shenzhen, including 5 oilfields. The average water depth of the oil field group is about 400 meters, making it the largest reef limestone oil field with geological reserves discovered in China's offshore areas to date. It is also the deepest offshore oil field group in China and has the largest underwater production system for offshore oil and gas fields in Asia. Its development technology difficulty and complexity rank among the top in the world. Over the past 20 years, Liuhua Oilfield has accumulated over 74 million tons of newly discovered geological reserves, with a total crude oil production of over 23 million tons and a total industrial output value of over 80 billion yuan. It has developed into the largest deepwater oil field group in China, with over 14,000 tons of crude oil extracted from the deep sea every day and continuously sent to nearly 30 refineries in coastal areas such as Liaoning, Shandong, Zhejiang, Jiangsu, and Guangdong, contributing outstanding efforts to ensuring national energy security. In February 1987, CNOOC Nanhai East Oil Company cooperated with foreign oil companies to discover Liuhua 11-1 oilfield with huge oil reserves at a depth of more than 300 meters in the middle of the Pearl River mouth basin in the north of the South China Sea. In March 1996, the Liuhua 11-1 oilfield was successfully put into operation, which was China's first all-sea underwater wellhead development model oilfield, representing the highest level of offshore oil development engineering in the world at that time. The oilfield development system consists of an FPS, floating production system, South China Sea Challenge, used for drilling and providing underwater support, as well as a 150000-ton FPSO, floating production storage and unloading unit. South China Sea Victory, equipped with production facilities and crude oil patrol systems. In July 2003, China National Offshore Oil Corporation, CNOOC, Shenzhen branch established the Liuhua Oilfield operation area, officially taking over the operation rights of Liuhua Oilfield. Liuhua 11-1 oilfield became China's first deepwater self-operated oilfield. On the one hand, the Chinese side actively strengthens the exploration and development of satellite oil fields, and on the other hand, actively analyzes the production dynamics of oil wells in the main area. The annual production of oil fields has rapidly increased to 1 million tons. Thanks to the iterative upgrade of development technology, in September 2012, Liuhua Oilfield became a new member, China's first fully underwater development oilfield, Liuhua 4-1 Oilfield. The project utilized multiple domestic pioneering technologies such as downhole dual electric pump technology and continuous laying of subsea pipe base plates, laying the foundation for China National Offshore Oil Corporation to move towards deep water. Between 2012 and 2015, researchers from China National Offshore Oil Corporation, CNOOC, Shenzhen branch explored and discovered the Liuhua 16-2 oilfield group, and successively overcame many world-class problems such as deepwater flow safety assurance and long-distance electric submersible pump power supply technology. They innovatively applied the FPSO plus all-underwater development model and successfully built the deepest and most complex FPSO, Offshore Oil 119, in China. On September 20, 2020, China's first self-operated deepwater oil field group, the Liuhua 16-2 oilfield group, was put into operation. The average depth of the 3 oilfields was 412 meters, marking a new milestone in China's deepwater oil and gas development. The daily crude oil production of the oilfield group exceeded 11,000 tons. Since the beginning of 2023, the Liuhua oilfield has further increased its output to contribute oil and gas. The daily oil production of the Liuhua 11-1 and 4-1 oilfields has remained stable at about 1,000 tons. The Liuhua 16-2 oilfield group has cumulatively produced over 10 million tons of crude oil, forming a unique integrated production and management model for deepwater oil and gas fields, including production, storage, and sales. In recent years, thanks to technological breakthroughs in the development of reef limestone oil fields, the recovery rate of Liuhua 11-1/4-1 oilfield has increased against the trend, ushering in opportunities for secondary development. The first cylindrical FPSO in Asia and the new Asia's first deepwater jacket platform have won the baton, which will make new and greater contributions to the high-quality development of oil fields in the eastern South China Sea. The cylindrical FPSO is isotropic and does not need to rotate with the wind, thus saving space and equipment costs for single-point layout. Additionally, there are relatively more risers, umbilical cables, and cables that can be connected. Compared to ship-type FPSOs, cylindrical FPSOs with small tonnage can meet the safety requirements of South China Sea operations and marginal oilfield production. Moreover, under the same function, cylindrical FPSOs can save billions of yuan in investment compared to ship-type FPSOs. With its advantages such as better stability, higher deck load, and the use of multi-point mooring systems to avoid the bottleneck technology problem of single-point mooring systems, cylindrical FPSOs have good prospects for promotion and application in the development of deepwater oil and gas fields in China. The cylindrical FPSO will form an oil field development facility with a deepwater jacket platform, HiG-2. The average depth of the sea area for the operation of HiG-2 is about 324 meters, with a total height of 338.5 meters and a total weight of 37,000 tons, reaching the capacity limit of domestic construction sites, transportation, installation equipment, and ships. Overcoming a series of technical challenges such as foundation settlement, large-scale lifting, weight and size control, loading and transportation, and installation during the construction process. In order to minimize the weight loss of the jacket, the project team and domestic steel companies jointly developed a new type of 420 megapascals ultra-high-strength steel thick plate suitable for marine engineering. The application of S420 grade high-strength steel in HiG No. 2 exceeded 20,000 tons. Through the application of this innovative material, not only has the key technology of lightweight design for ultra-large marine platforms been overcome, but the HiG No. 2 jacket has successfully reduced weight by 500 tons, saving billions of yuan in material and ship renovation costs, and has opened up a new path for the large-scale application of domestic high-strength steel in marine engineering. The project construction applied a complete set of independent design and construction technology for a 300-meter deep jacket, and completed the construction of the jacket in just over 26 months, with key dimensional accuracy controlled within 5 millimeters. To build the first smart jacket in Asia that integrates digital twins, marine environmental monitoring, and underwater environmental monitoring systems, and to apply sacrificial anode and external current cathodic protection technology for the first time in deep waters exceeding 300 meters, providing dual protection against corrosion for the jacket and ensuring that HiG-2 remains neutral in the deep sea for a longer time. The deep sea, with a depth exceeding 300 meters, is the main replacement area for global oil and gas resources. In recent years, China has explored and developed 12 oil and gas fields in deepwater waters, with an annual production of over 10 million tons of oil equivalent in deepwater oil and gas, of which more than 90% come from oil fields in the eastern South China Sea. China's deep-sea oil and gas, represented by the oil fields in the eastern South China Sea, are becoming an important force in ensuring national energy security.